My name is Marlon Cook. I'm a hydrogeologist with Cook Hydrogeology, LLC. I was asked by the Mobile Bay National Estuary Program to evaluate hydrogeologic conditions at the Plant Berry Coal Ash Pond located in northern Mobile County on the west side of the Mobile River. The purpose of my presentation is to show actual data from the area that will describe the coal ash pond and the hydrogeology in which that coal ash sits. I looked at three primary hydrogeologic issues related to the coal ash pond closure. These issues are related to the geology and the hydrogeology of the area. I reviewed a number of available documents with information related to the hydrogeology of the area, including a number of Alabama Power Company documents. I also reviewed the Mobile Baykeeper pollution report on the coal ash at Plant Berry, available well records from the Geological Survey of Alabama, various geologic maps, groundwater availability reports, and other topographic maps and aerial imagery of the area. The first hydrogeologic issue is the hydrogeologic isolation of the coal ash and chemical constituents. In order to be a viable closure, the chemical constituents that are contained in the coal ash must be isolated from the surrounding environment. This is a geologic map of the area. There are two primary geologic units. The first one is alluvium. These are relatively recent deposits on either side of the Mobile River that are placed there when it's in flood. These are deposits that consist of sand, silt, clay, and even some gravel. And the alluvium is about 130 feet thick at Plant Berry. Blue line west of the river is the separation between the alluvium and the older age sediments of the Miocene undifferentiated. The Miocene deposits are primarily sand and clay. They were deposited in a number of different environments, fluvial, nearshore environments, so they're both terrestrial and marine. Those Miocene deposits in this area are about 600 feet thick, and they underlie the alluvium and the Mobile River. Alabama Power Company constructed 16 monitoring wells around the perimeter of the coal ash pond. These wells are all constructed in the alluvial sediments, and they were constructed there for three primary purposes. One is to determine the lithologies of sediments. The second one is to allow sampling of the water in the alluvial sediments, and the third is to obtain water levels to construct a potentiometric surface map to show the direction of groundwater movement underneath the coal ash pond. The first component of the hydrogeologic isolation of the coal ash is to look at vertical isolation. This would be the movement of water and contaminants through the coal ash and then downward into the alluvial sediments. Are the clay units underlying the ash pond homogeneous, impervious, and continuous? We know that there are clay layers that separate the coal ash from underlying sands. The characteristics of that clay are important in being able to determine the potential for vertical isolation and downward movements of contaminants. Alabama Power had taken 7 wells on the western perimeter of the coal ash pond and constructed a hydrogeologic cross-section. Hydrogeologic cross-section really is a graphic of sediments, and then from point to point or well to well, you can create essentially a layer cake and be able to see the characteristics, both hydraulic and geologic, of sediments along that cross-section. And you'll see here that the gray dotted section of the cross-section at the land surface is the coal ash. Then underneath that are the tan and orange layers that are a mixture of silt and clay that separate the coal ash from the underlying aquifer. Underneath that is the actual alluvial aquifer, which is a silty sand. That's Unit 3. And then below that is the upper Miocene, which in this area is a continuous layer of clay that is anywhere from 20 to 50 feet thick. This cross-section has at least 5 different layers, and these layers are not homogeneous. They consist of impermeable clays, but also have some sandy and silty clays interbedded. This cross-section also has water levels, and those are the blue numbers up in the coal ash, and that does indicate that water levels in these wells rise above the top of the clay layer, which means there is some level of hydraulic confinement of the alluvial aquifer. So, are the clay layers underlying the ash pond homogeneous, impervious, and continuous? No, they're not. The clay layers are not homogeneous. We see from the cross-section that they're a mixture of sand, silt, and clay, and those layers are interbedded. There are some massive clay layers, but some of the units contain silt and sand. Testing by Alabama Power shows that average permeability overall is about 10 to the minus 7th. This is a fairly good confining layer, but it is not totally impermeable. So the clay unit is continuous, and it varies in thickness from 4 to 28 feet, but it is variable. So the conclusion is that the clay layer forms an effective aquiclude, but it is not totally impermeable to downward movement of water. The next question is, if the clay layers underlying the ash pond form an effective aquiclude, then why have coal ash contaminants been found? The samples that Alabama Power collected from their monitoring wells show that contaminants from the coal ash have moved through the clay layer and into the underlying alluvial aquifer. The standard, which was established, which is the maximum contaminant level established by EPA, is the drinking water standard for arsenic, and that is 0.01 milligrams per liter. The other contaminant found in the alluvial aquifer is cobalt. There is no established standard for cobalt concentrations, and so EPA required Alabama Power to determine a background concentration, which is a calculated value, and that value is 0.01794 milligrams per liter. Samples show that there have been contaminants that have moved through the clay layer and into the underlying alluvial aquifer. So you'll see there that the maximum concentration found has been 0.0671 for arsenic and 0.0343 for cobalt. The next question is, how will the in-place closure plan address contaminant movement into the alluvial aquifer? So one of the primary tasks in the coal ash pond closure plan is to dewater the ash. This will accomplish 2 important goals. Number 1, mobilization of the chemical constituents in the coal ash occurs in water. The constituents will not move if the ash is dry. And the second point is that dewatering the ash and removing all the free water in the pond will reduce the hydraulic head in the pond, thereby reducing the downward pressure. And so this reduces the means that the contaminants have to move downward into the alluvial aquifer. So it's critical that the coal ash be dewatered. If we're talking about vertical isolation, then is the alluvial aquifer underlying the ash pond confined? You'll see in this graphic that it shows a confined aquifer, and that is that a well drilled in an unconfined aquifer, the water does not rise above the top of that unit, showing that there is no hydraulic pressure on that unit. This graphic also shows movement of water from an upland area toward the nearest stream. And this is the case at Plant Berry, where groundwater is moving from west to east or from upland areas to the Mobile River. And this is a very important point in determining if the coal ash is isolated from the surrounding environment. We go back to the line of cross-section that I showed earlier to take a look at the actual potential for confinement of the alluvial aquifer underneath the coal ash pond. The blue numbers, which for monitoring well 5, MW5, the water level in that well is 5.49 feet for one of the times when the water levels were measured. These water levels are measured in these wells about every 6 months. So you'll see as you go across, that blue line shows the potentiometric surface, or the surface of the water that is established by each water level in each monitoring well. So that blue line rises above the clay layer that overlies the alluvial aquifer, indicating that there is some level of confinement here. I wouldn't say that the alluvial aquifer is highly confined, but the fact that these water levels are above the top of the stratigraphic unit show that there is some level of confinement there. And this is an important point because the water level in these wells is rising above the aquifer, showing that there is some force upward instead of all the water moving downward. I took Alabama Power's information about their 16 monitoring wells and calculated the head on each one of those wells. And so at the bottom of the table there, you'll see a row of that table titled head. The head in these wells range from MW1, which was 13.97 feet, to well MW7, which is 55.7 feet, showing that there's a significant upward pressure and significant head on these wells. The question is the alluvial aquifer underlying the ash pond confined? All 16 of those wells have positive hydraulic heads from 13.97 to 55.7 feet. So the conclusion is clay layers underlying the ash pond form an effective confining unit. This doesn't mean that all water and contaminants are contained above the aquifer and will not move into the alluvial aquifer, but it does show that there is a limiting factor there, and that's also seen in the concentrations of arsenic and cobalt, which are relatively small, but those contaminants being there also show that this is a leaky confining unit and does allow some movement of water into the alluvial aquifer. The next issue that we'll look at is horizontal isolation. So what is the direction of groundwater flow in the Plant Barrier area, and what impact does the Mobile River have on groundwater flow? So if contaminants are getting into the alluvial aquifer, where will they go? And is there any possibility that contaminants will move into the Miocene aquifer? And this potentiometric surface map that was constructed from water levels collected in these wells in January 2018 shows that the groundwater in the alluvial aquifer is moving from the upland area west of the facility toward the Mobile River. The highest water level measured in January 2018 was in well MW1, which was 3.67 feet. And then the lowest one was in MW9, which is 1.09 feet. And then the contours show that groundwater is moving toward the river. So this means that there is horizontal isolation there. The hydraulic gradient, which I calculated from the water levels in those wells in the alluvial aquifer, is 0.0003. This is an extremely flat hydraulic gradient, meaning that groundwater movement is very, very slow. The Alabama Power consultants calculated flow velocity for groundwater in the alluvial aquifer, and that was 2.92 feet per year. So that shows the slow movement of groundwater underneath the coal ash pond. This also means that contaminants in the alluvial aquifer will eventually flow into the Mobile River. There has been some monitoring of the Mobile River, and there have been no detects of any of the coal ash contaminants in the river, and that's primarily due to dilution of relatively small concentrations of contaminants flowing into a big body of water. Horizontal movement of the coal ash and its chemical constituents at the ground surface is dependent on the dike that surrounds the pond. This is an engineered structure, and so I didn't evaluate the viability of the dike in this particular assessment. The next question is, what is the potential for the Mobile River channel to relocate through Plant Barrier and the coal ash pond? The Mobile River is an old age river, which means that it has a wide area of channel migration, as that channel has meandered across a wide floodplain over geologic time. The coal ash pond is located on a point bar of the Mobile River, indicating that channel is actually moving to the east away from the coal ash pond. So that's a good indication that there would not be any impact from migration of the river channel. So the question was, what is the potential for the Mobile River channel to relocate through Plant Berry and the coal ash pond? The conclusion is that the potential for a meander cutoff at Plant Berry is not realistic. The ash pond is located on a point bar, therefore the channel is migrating eastward away from the facility. Is it possible for Mobile River flooding to overtop the coal ash pond dike? This would be a catastrophic event. Alabama Power has determined that the dike around the coal ash pond was constructed to withstand a 1,000-year, 24-hour rainfall event. This would be a major rainfall event right at the facility. The dike was also constructed to an elevation of 21.5 feet. The 100-year flood elevation at the Plant Berry facility is 16 feet, and the flood of record was 18.19 feet in 1961. So this means that the dike was constructed so that it provides a pretty robust level of protection for the coal ash. But the question here is more if there was a catastrophic flooding event, one that has not been seen previously, then could the dike withstand that? So combinations of future climate factors such as rising sea level, a major upstream flood, and a severe tropical storm could cause a catastrophic flood event on the Mobile River that possibly could inundate the coal ash pond. So the question is it possible for the Mobile River flooding to overtop the coal ash pond dike? The conclusion is that a catastrophic level flood event on the Mobile River at the coal ash pond site has not been simulated. So whether the coal ash is excavated and relocated or capped in place, the impacts of flood of this magnitude during the next 20 or 30 years when the coal ash is being capped or moved should be considered, and the impacts of an encapsulation structure for an indefinite time period should be a part of an in-place closure plan. So both Cook Hydrogeology and the Mobile Bay National Estuary Program Science Advisory Committee has recommended to Alabama Power that they do simulations on various major flood scenarios. So let's look at another issue here, and that is, what if the coal ash has been excavated and moved to an upland landfill? It still must be isolated from the surrounding environment. The nearest available landfill that could potentially contain the excavated coal ash is the Turkey Trot landfill northeast of Citronelle. We have to dispose of our waste, and so we typically dispose of it in landfills. And most of these landfills are in upland areas. I know experience of others have done research on landfills show that they do leak. Water gets into that waste and creates leachate. That leachate moves laterally and discharges into streams and into aquifers. So this is a geologic map that shows the location of the coal ash pond and then the Turkey Trot landfill just into Washington County. The yellow is alluvium and the alluvial aquifer. The tan or brown color is the Miocene undifferentiated, and then the white or light tan is the Citronelle formation. Both the Miocene and the Citronelle formation are aquifers. The Citronelle is primarily a local aquifer that provides water for irrigation and domestic use, but the Miocene aquifer is the primary aquifer for all groundwater supplies in Mobile and Baldwin counties. This is a map of recharge areas for aquifers. So you see here that we have our three primary geologic units, the alluvium, which is the yellow, the orange tan color, which is the Citronelle formation, and the dark gray or brown, which is the undifferentiated Miocene. So you see the Turkey Trot landfill location, which sits on the recharge area for the Miocene aquifer. If the coal ash is excavated and moved into that landfill, then every precaution will have to be made to make sure that we protect the recharge area for the Miocene aquifer from any movement of contaminants. To determine if that is a viable option for long-term containment, we also need to have a comprehensive evaluation of whichever landfill is selected in the case of excavation and movement of the material, to make sure that material remains isolated from the surrounding environment. In the early 60s, when storage pond was opened, we didn't have the knowledge and the regulations we have today to protect our environment. The fact is, it is there. And so the main issue is going to be, is that ash isolated from the surrounding environment, and which is the best way possible to have long-term containment. My evaluation shows that there's probably no perfect solution. The decision has to be based on the best science and engineering and not just perceptions that we have about what might happen. From a hydrogeologic perspective, my assessment, I think, shows that capping in place is viable. There is possibility for vertical isolation, and also with the movement of groundwater toward the river, we have some hydrogeologic isolation of the material. But the long-term containment of the ash is going to be based on engineered structures, and those structures have to be viable, they have to be sustainable, and they have to be maintained over an extremely long period of time into the future.